Hi, my name is Sharon Katz, and in this video I will try to explain how Meltdown attack is working. This will be a simplified explanation of the Meltdown attack, and we will only try to see how we read 1 byte of memory from a place we should not have access to. Meltdown attack has two major phases. The first phase is getting the data from somewhere in the memory we should not have access into a part of the CPU. Even though this part of the CPU cannot be read by us. The second phase will be using a known attack in order to get the data from the place in CPU where it is put. This reading of this data will not be a direct read because we are not allowed to, but it will be as if we are seeing the shadow of the data and guessing the data by doing some kind of a trick. This video does not assume you have a thorough knowledge of how the Intel CPU is built or about the architecture and microarchitecture of the Intel CPUs, but it is important for us to understand the basic concepts of it. And so I will explain it very shortly and simplified. First, the difference between architecture and microarchitecture. The architecture of a CPU is the way the CPU behaves when it runs our assembly code. Every program or software that we write is compiled and built into assembly code, which is fed into the CPU and is run in sequence. And the architecture of the CPU promising that if you run the assembly code, you will get this result in a predictable or unpredictable way. The microarchitecture, on the other hand, is how the architecture is implemented within the silicon, within the hardware itself. It can be in different ways and it can be inconsistent between one CPU to the other as long as it promises to implement the architecture that is documented. Let's take, for example, two commands, one very simple and one a little bit more complicated. A simple command like add, when you add two operands and put the result in another memory or register, is a simple operation which is usually done by silicon. It is done very fast and it usually is very straightforward. If we take another example of cache invalidate, which is a little bit more complicated, here it is usually not done directly in silicon, but it has some kind of a code that runs within the CPU. It is called micro instructions. The micro operations or micro instructions are like an assembly that runs within the CPU and implementing the commands which are a little bit more complicated, like the example I gave of cache invalidate. An important difference between architecture and microarchitecture is that architecture is protected. We will never have any value that we shouldn't have in any register that we can access. But microarchitecture does not take measures to protect data because it's all in the CPU. If there is some kind of a memory read that is not allowed for us to access, it can be inside the CPU somewhere and it is not protected, but the hardware assumes that we will not be able to reach it. This is the basic of the meltdown because we will get the data we want somewhere in the CPU and we will later get it out, but it is not protected at the level of the microarchitecture.